The second free response question has some consistencies with regard to modeling functions and their rates of change especially, and then also looks into the domain and some of the tendencies for the graph in how the rate of change is itself changing. So looking at this question right here, what you see is you're given two scenarios for this function p. So the first scenario is when t is equal to 0. So the input is 0, has a corresponding population of 270. So I'm just going to write that as 1 point, and then I'm going to write the other situation, which is a t value or input of 6 that yields a population of 720. So there are the 2 points that we're looking at to start this function. So based on that data, it's asking write two equations that you can use to find constants a and b. Well, these are the input outputs to find a and b. So let's look at the first situation. If we take our function right here, an output of 270 is equal to a plus b times the quantity ln of t, which in this first case is 0, plus 1. So this right here is one of the equations that we can use to solve this. So I'll enter that into my cell. And then the second equation is for the scenario number 2. So the output of 720 is equal to a plus b times the ln of the input 6 plus 1. And so here again, if we're just putting our inputs and outputs into the given function, we get our second equation. So there's our two equations. In order to actually solve these, I'm going to go back this first example right here. I'll just move this down. And I'll solve for this. Since I know that I take 270 is equal to a plus b times the ln of, well, 0 plus 1 is 1, and the natural log of 1 has to have a value of 0. So I can replace this with 0, and 0 times b is a value of 0, and so all of that allows us to find that the value of a is 270. Once we know that's the case, we can take this second equation here, so I'll move down again, and we can substitute in 270 for a. So looking at that equation, I get 720 is equal to 270 plus b times the ln of 6 plus 1, which is 7. And so if I continue to solve this equation, I subtract 270 from both sides. Subtracting 270 leaves me with 450 is equal to b times the ln of 7. And then I can divide both sides by the ln of 7, the natural log. So divide by ln 7, and that is my b value. And so there is my second solution. B is equal to 450 divided by the ln of 7. So there's my first two answers. Hey, once I have this information, what I can now do, or I can move to the next where it's asking me for the average rate of change. Remember, average rate of change is a slope. So the slope from 0 to 6 years. So here we'll come back and we'll write basically, I'll call it rate of change equation, and that is just the difference between the x, or the difference between the rise and the run. So if I take the situation y2 minus y1, and I put this in grouping symbols, divide by the change in the corresponding x's, x2 minus x1. So this is going to give me my rate of change, and so I can just plug in the known quantities. So my first set of points, the y2, y1, I come back up here, 720 and 270. So if I take the difference of 720 minus 270, and I divide that by the difference of the corresponding x's, which are 6 and 0, so 6 minus 0, and that's going to give me my rate of change, which here I can calculate. I see it's 75. So my rate of change is 75, and the expression that I used to find that is just this equation, 720 minus 270 divide by 6 minus 0. Oops, I have those in the wrong spot. So the 75 goes up here, and then the formula for the rate of change was here. Now, once I have this, it's asking me, can I use that that average rate of change to estimate what the population would be when t is 11? Well, the easiest way to think of that is I have the scenario when t is 6, right? So if I start with that value of 720, and then I just add the rate of change, which is 75, times the number of years to go from 6 to 11. Well, 6 to 11 is 5 more years. And so that's going to give me my solution of 1095. And the work that leads to that, this was my actual work as well. So I can actually put the same thing for both of these. That's the equation that I used. Now you could also go back in and do this whole rate of change equation right here. Plug in 75 for the rate of change, and then you can just use 11 and the y of 11, or the output of 11, p of 11, in one of these calculations. However, just building from what you have at 6 years is the easiest. So the next question is to consider the rate of change here, and you need to determine whether those rates of average rate of change is more or less than it's going to be from when the t-value is greater than 6. Well, in order to do that, what I need to do is I need to look at what that graph looks like. So I'm going to come back and I'm going to type this whole function in my p of t. And I have my a value, again, which I found to be 270, plus my b value, which I found to be this calculation of 450 over the natural log of 7, times ln of x plus 1. And remember, we do have to change these, go back to this, in terms of x. The input needs to be x. So here is my graph. Now, this graph kind of looks like it's a vertical line, right? So I need to zoom out because I'm expecting it to be a log until I see the sort of the form of the log. Well, here now I see the log function. And so in looking at this, I can answer these questions. Here, the average rate of change. As you look at this, here's 6, and then as you get bigger than 6, what's happening is this graph is flattening out. It's getting less, it's increasing by less and less. The fact that it's increasing by less and less is another way of saying that the average rate of change from when values of t are greater than 6 are going to be less than they are here, the early stages where it's more vertical. And the explanation is because the way that this graph, it is increasing but concave down. That means that the rate of change is decreasing. So when you look at this, the graph of the function is always increasing, and it is concave down. So you can see here's the two critical elements. And so as t increases, the rate of change, even though they are still increasing, or are still positive rates of change, they are getting less and less. They're increasing by less and less, and so that means that they are, the rates of change are getting lower or decreasing. So that would be my explanation for this. Finally, the last one is if the population is a max of 940, what I need to do is look on my graph when y is equal to 940. I can cut this off and see, zoom in. This right here is the maximum value for my t input. So I see here it's between these first two. Well, I know that my function is increasing always. It's going up and to the right. It's not decreasing. So here I can just use those keywords. I have an increasing function where the maximum p-value is going to be 17. And so that's going to give me my the limit on my domain. Okay? And so those would be my solutions.